Hello and welcome to this presentation on how to protect your data using Application Layer Encryption. My name is Kim Christensen and I'm working for Cybercrypt as a lead software engineer, and I joined Cybercrypt in January 2022 focusing on security in the cloud. Today I'm going to talk about why you should protect your data, different types of data protection, and then talk about how easy you can protect your data using Cybercrypt D1. In the end, I will talk about how to make your encrypted data searchable. Why should you care about data protection? In 2021, there was around 5,250 confirmed data breaches, impacting almost 300 million people. Most of them were caused by human error, like default passwords and insecure configuration. With the average cost of a breach being almost $4 million, it's not only a privacy concern, but it's also very costly for your organization. In addition to this, more than 50% of companies says that the IT department is not ready to handle a sophisticated cyber attack. Cyber attacks can happen to companies of all sizes, from Twitter, Walmart, and Samsung to universities, healthcare, and travel agents. Some examples are Deakin University, Infinity Rehab, and ClearTrip. Let's talk about some of the lesser-known data breaches. Deakin University is a university based in Victoria, Australia. A breach was first discovered on July 10, 2022, when an attacker used a staff member's username and password to access student information via one of Deakin's third-party providers. Personal information of almost 47,000 students was stolen. Soon after, almost 10,000 students received an SMS scam message. Recipients that opened the links in the SMS was led to a page that requested personal details and credit card information. Infinity Rehab is a provider of therapy services based in Oregon. Details around the breach is not clear, but what we know is a network utilized by one of their associates was breached between January 19, 2022 and March 17, 2022. During that time, an unauthorized party potentially removed files from the network. The type of information compromised may include social security numbers, driver license numbers, medication information, lab results, and more. On July 13, 2022, Infinity Rehab began notifying over 183,000 individuals potentially impacted. ClearTrip is a popular travel booking platform based in India. On July 18, 2022, they confirmed a major data breach after hackers posted stolen data on the dark web. Officially, ClearTrip have stated that no sensitive information was compromised. But the data dump posted on the dark web indicates that internal financial data, refund information, and commissions was leaked. What can we learn from this? Breaches are often discovered a long time after they happened. According to researchers, the average time to initially detect a breach is 212 days, making it very hard to figure out what data has been compromised and who have been affected. Attacks can happen to everyone, from major corporations to small companies. All this combined makes it very important for organizations to efficiently protect their data, both for their own sake, but importantly also for their customers. Let us talk about some different kinds of data protection and why they aren't enough in today's threat landscape. Let us imagine a very typical setup. We have an application that talks with a server and stores some data in a database. The most common form of data protection is encryption in transit. It protects data during transfer between devices and networks, such as the internet, within a company, or being uploaded to the cloud. When you access a website over HTTPS, this is what happens. Your data is encrypted between the application and the server, but as soon as the data reaches the server, it will be decrypted and the server has full access to the data. Encryption at rest protects the data when not in use. When the data needs to be processed, it will be decrypted. Cloud providers offer at rest protection for most kinds of storage. The downside of this is that encryption keys are exposed to a third party, Operators could access the data, and services reading the data will have to have the encryption key to decrypt the data, introducing a weak point in the security. Very often, in-transit and at-rest encryption is combined, but the data is still exposed on the server to operators and of course in the application. Application-level encryption shifts the encryption all the way to the left. The application handles the encryption and decryption without the involvement of the server or database. The result is that a breach won't expose any sensitive information as they have no knowledge of how to decrypt the data. But there are also downsides to application-level encryption. For example, server-side processing is harder and a lot of the built-in database functionality cannot be used on the encrypted data. How do you make application-level encryption easier? CyberCrypt D1 is a product that will help you integrate application-level encryption in your application without any impact on your business logic. What does CyberCrypt D1 provide? It provides application layer quantum-resistant encryption, fine-grained OAuth 2 and OIDC authorization, and object-level key management. How will the architecture look if you introduce CyberCrypt D1? If we again take a typical application setup with in-transit and at-rest encryption, and then introduce CyberCrypt D1, it will look something like this. The user authenticates with an identity and access management solution, giving you a unique token representing the user. Next, the application communicates with D1, forwarding the identity token and the data that should be encrypted or decrypted. Before processing the data, D1 verifies the identity token and then uses the identity to encrypt or decrypt the data. The result is returned to the application, who then communicates with the server. By using the identity from the IAM solution, we are able to encrypt or decrypt the data based on that identity. The recommended setup for D1 is to use an end-user identity and not an identity tied to the application or server, as it provides the highest level of security and flexibility. Now let us take a look at a short demo of CyberCrypt D1, showcasing how easy it is to start using application-level encryption without affecting any business logic. The demo is using the official sample application, How to Use ASP.NET Core and Entity Framework Core from Microsoft. Entity Framework Core is an ORM tool that helps developers communicate with different databases. I will show how to configure Entity Framework Core to use CyberCrypt D1 to automatically encrypt and decrypt database columns containing sensitive data. We support other types of ORM tools and programming languages, but in this demo, I will focus on the .NET Entity Framework Core stack. This is the sample application I will integrate into CyberCrypt D1. As mentioned, it is the official Microsoft sample showing how to work with ASP.NET Core, Razor Pages, and Entity Framework Core. The website is made for a fictional university called Contoso University. It includes functionality such as student admission, course creation, and instructor assignments. Users can then view and update student, courses, and instructor information. The UI is not the prettiest UI. It is based on the built-in project templates and focuses on how to use Entity Framework with ASP.NET Core, and in our case, CyberCrypt D1, not customizing the user interface. The only change I have made to the original sample is to add student emails. In this demo, I will handle emails as sensitive information that should be encrypted. All other data is not encrypted or changed in any way. This represents a typical use case, as you most often don't need to encrypt all data in the database, but only the columns containing sensitive information. Now let us take a quick look at the individual pages. This is the students page, where you can create new students, search existing students by name, and have a list of all the students currently enrolled in the university. You can see their last name, the first name, and the email, the enrollment date, and then you can delete or edit the individual students. You can also see more detailed information. Then we have the courses page, where you can get a list of all the existing courses and the department, and you can of course also create and delete existing courses. The last page we will take a quick look at is the instructors page. You can create new instructors, and you can of course see a list of existing instructors and the courses they are handling. The page we will focus on today is the students page. Let's take a closer look at the page itself. You can show details of an existing user. You can go back and forth in the list of the current students. And you can search existing students by name, but not by email. Now let us take a look at the database. Here we can see all the different tables that exist in the database. Courses, departments, enrollments, instructors, and students. In this demo, the important table is the students table. As we can see, it has a column called email that contains text. If we take a look at the data in the students table, you can see the first name, the last name, the enrollment date, and you can see that the email is stored in clear text. Now let us take a look at the code itself and see how few changes you have to make in order to integrate CyberCrypt D1 into your application. The first thing I will do is to add a configuration that indicates if the communication with the D1 service is happening over a secure channel. In this sample, we won't use a secure channel, but the code will handle both situations. Then we will read from the configuration where the D1 service is located and read the information about username and password in order to securely communicate with the CyberCrypt D1 service. The last thing we have to do is to inform the ASP.NET framework how to get a D1 client when needed. This is done by injecting a function that returns a new D1 client every time it is requested. This is important as the web server can handle multiple requests at the same time for potential different end users. This sample won't use OAuth2 or OIDC authorization, but rely on username and password, which isn't recommended in production. If you want to use OAuth2 or OIDC integration, it can be done in a lot of different ways depending on the application and IAM system. A quick and dirty way to implement it is something like this. When we construct a D1 client, we want to read the authorization header from the request. To do that, we must inject an IHTTP context accessor into the system. When we build the D1 client, we then extract the OIDC token from the authorization header and use it as credentials for communicating with CyberCrypt D1. As said, this is a quick and dirty way of implementing OIDC authorization in the application. This is not the way it should be implemented in production. For the sake of simplicity, I will remove the OIDC authorization and use username and password. The second thing we have to do is to change the database context created for the database. Normally, the context inherits from DB context. To use in a CyberCrypt D1, we have to inherit from D1 DB context instead. We also have to change the constructor to accept a function returning D1 client and pass it on to the base class. The last thing we have to do is to find the property in the model that represents the column in the database we want to encrypt, and then add a confidential attribute to the property. And now CyberCrypt D1 have successfully been integrated into the application. If we again take a look at the database, you can see that the tables are the same and the student table looks exactly the same. But if we take a look at the data in the students table, it is clear that the email is no longer stored in clear text. Now let's try and create a new student with the name Kim Christensen and the email kch@consoso.org. Just to verify that the student has been successfully created, let's try and search for it. And there it is. Looking in the database, we can also see the new student and of course see that the email is not stored in clear text. When we start to encrypt the data in the application, we also lose some functionality. Searching and filtering becomes hard as the server or database isn't able to decrypt the data. But with the right implementation, it is possible to do so without leaking sensitive information. Let us first go over some of the general challenges with searchable encryption. The most obvious is that you have to figure out how to search in data you aren't able to decrypt. For example, the built-in database functions for searching cannot be used as it doesn't understand the data. The result is that most implementations requires you to define keywords up front. When you start to define keywords, even the number of keywords will provide an attacker with valuable information, for example, the number of unique customers. The same goes for the correlation between keywords and data, as it can be used to perform de-anonymization attacks. An example could be that you have a solution that tracks GPS data from phones. All sensitive information like the name of the user and the home address is encrypted, but the solution allows you to search for specific user's coordinates. If the attacker knows the home and work address of a user, easily found through Facebook and LinkedIn, they can use the correlation between the keywords and the data to locate a specific user based on the patterns in the data. So how does CyberCrypt D1 handle these challenges? You have to define keywords up front, but keywords are not leaked as they are encrypted in such a way that an attacker won't be able to see them. The number of keywords are not leaked either. They are encrypted in a way that won't leak how many keywords that have been defined. Correlations are not leaked either. Now let us see the CyberCrypt D1 searchable encryption in practice. I will continue using the application from the previous demo and show how easy it is to integrate it into the application. In order to integrate searchable encryption into the application, you have to do two changes. The first change you have to do is to update your database model, indicating the property that needs to be searchable. The argument to the asSearchable method takes the value as input and returns a list of the keywords for that input. In this case, it will just return the same value, meaning that for searching emails, you would have to search for the full email, including the initials and the hostname. If we wanted to be able to search for the initials only, we would have to take the value and split it at the @ sign and take the first element. But to keep it simple in this sample, we will only allow searching for the full email. The last thing we have to do is to adapt the searching logic to also support searching for emails. Searching in encrypted data is fundamentally different from using the normal searching capabilities in the database. To enable it anyway, we need to query the data in a different way. Instead of talking with the database, we need to talk with D1 to perform the searching based off the keywords provided. In the case of Entity Framework call, this is done by using the where searchable function instead of the normal where function. The function takes two parameters: the property that we need to perform the search on, and a string containing the keyword we want to search for. In order to support both name searching and email searching, the last thing we have to do is to combine the result of the two operations into one. To verify that our changes actually works, let's try and search for the email of the student called Kim Christensen. The email is kch@consoso.org. And here it is. We have successfully implemented searchable encryption into the application. Now you have seen how easy integrating application level encryption into your application can be. I hope this inspires you to incorporate application level encryption into your architecture and protect your data against cyber attacks. Remember that companies of all sizes are at risk. Actually, 43% of cyber attacks are aimed at small businesses, and 66% have experienced a cyber attack in the past 12 months. Start protecting your data and application today, both for your business and for the sake of your customers. Thank you.